Hi students, this is AJ sir. Let's study 9th standard ICSE Math, Chapter 21, Solids, Exercise B, Cross Section and Flow of Water. Also, to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. Let us first understand the formulae which would be required in this exercise. What is a cross section? If I take a slice of this three-dimensional object, I get a two-dimensional surface. That is called a cross section. Simply speaking, it means a slice. Now there is a formula that volume is equal to area of cross section into the length, or it could also be called the depth. For example, what is the volume of the cuboid? We know it is length into breadth into height. But there is another way to calculate the volume. What if I give you the area of this cross section? Area of this rectangle. That is length into breadth is given. So now all you need to do is multiply it with this height. Or you can call it the length or the depth. Doesn't matter. But you will get the answer of the volume. So if the area of cross section is, let's say, 10 centimeters squared, and this depth is 10 centimeters, then the entire volume will be 10 multiplied by 10, 100 centimeter cube. Take the volume of the cylinder, although it's not in our syllabus right now. If you want to find the volume of the cylinder, first you need the area of this circle, which is a cross section. Area of circle is pi r square, of course, into the depth or the height. And indeed, the formula of volume of cylinder is pi r square h, which you will study in 10th standard. This formula, volume is equal to area into length, works only if the cross section is uniform. It won't work for this cone because the slice out here will be bigger than the slice out here. You can see the difference in these cross-sectional area. Only if the cross-section is uniform will it work. Which is fine because in our exercise, all solids will have a uniform area of cross-section. So how to remember this? Well, area is centimeter square, length is centimeter, centimeter square into centimeter is centimeter cube, which indeed is the formula or the unit of volume. Similarly, we can find the surface area, which is perimeter into length. Now notice one thing, perimeter is always a one-dimensional quantity. It's measured in centimeters. And length is also in centimeter. So centimeter into centimeter is centimeter square, which is the unit of area. So that way it makes sense. But let's understand this visually. If I ask you, what is the surface area of this cuboid? But I'm talking about the lateral surface, okay? Not the cross section. That is not this face, the front face and the back face. No, only the four walls of it. The top, bottom, right hand side and left hand side. The lateral walls. You have learned the formula for that. But now we have another way of calculating the surface area. First, calculate the perimeter of this cross section, which is length into breadth. And then, length plus breadth, plus length plus breadth. Length into breadth will be the area, but perimeter is 2 into L plus B is the perimeter. And then multiplied with the depth or the height, which is H. So now what is the formula for the lateral surface area of this cuboid? Perimeter, as I said, is 2 into length plus breadth. And I call this the depth because otherwise it's confusing. You call this the length and this is also length. Anyway, symbol H. And isn't this the formula you have already learnt? So you see, it's one and the same thing. When we'll do sums, we'll realize why this new formula can make calculations simpler. Note that solved example number 13 is cancelled because it's very huge and complicated. So not in your syllabus. Now in exercise 21b, let's start with the third sum. The cross section of a tunnel perpendicular to its length is a trapezium. What they have shown is a trapezium, but this is a cross section of a tunnel. The actual tunnel, you can imagine, is three-dimensional. You can imagine that here's a car. I'm only showing the back side of the car. It's moving inside this page. It's going inside the book or coming out of the book. This, I call this the depth, which is not shown in the diagram because it's a two-dimensional page. So if you take a slice of the tunnel, it looks like a trapezium. AB is obviously the road, AD and CB are the side walls, and DC is the roof. Maybe there are some bulbs or lights on the roof. Now I've just made this tunnel out of paper, so you can see this one is not a tunnel with a trapezium cross section. If I take a slice of this tunnel, it's a circle, and then there is a depth, and the cars move inside the tunnel like this. Same way, we have a tunnel here, and there is a cross section which is a trapezium. Now if I wanted to know the total area of this tunnel, this is the area of the tunnel, the walls of the tunnel. What I can do is, I can take the perimeter and multiply it with the height. So I'll get the curved surface area. So even in this sum, they have asked us to find the cost of painting the internal surface of the tunnel at this rate, excluding the floor. Obviously the floor is not painted. Now the rate is per meter squared, so that's a hint that cost will be equal to area into rate. But how do we find the area? And by area, they mean the area of this wall, AD wall, the area of the roof, DC, and the area of the wall, CB. Area of CB is actually a rectangle. DC, the roof, is also a rectangle. There is a depth. And AD is also a rectangle. So there are three rectangles out here. We have to find the areas of these three rectangles so that we can add them and we can multiply it with the rate to get the cost. Some dimensions are given already. AM, BN, AB, CD is given. The height of the tunnel is given. It's 2.4 meters. That is DM and CN. Now instead of finding the three rectangles areas separately, one short way to do it is, how about we do perimeter into the depth? That's a new formula we just learned. Note that when I'm calculating the perimeter, I am not including AB because they mentioned excluding the floor. That's why. Yeah, you can calculate the three areas separately also. You'll get full marks, but that will be a little longer. So what's given is AB is totally 7 and DC is 5. So let me write here 5. That means MN is also 5. Opposite sides of a rectangle. And they have mentioned that AM and NB are equal. They have mentioned it. If I assume AM and NB to be X and X each, and I know that AB is totally 7, it's given out here. So now tell me, how much is AM and NB? It is 1 centimeter each. 1 meter each. Also the height is given as 2.4 meters. So this is 2.4. So once you get DM and AM, using Pythagoras theorem, you can find AD also, which will come out to be 2.6 meters. So now the perimeter is 2.6 plus 5 plus 2.6, and if you multiply it with the depth, which turns out to be 40 meters, you get the total area of the surface to be painted, and then multiply that with the rate, you will get the cost of painting. So that's how you solve Roman number 1. So the steps are here. First we let them to be x, then we know that opposite sides are equal, we get the value of x, we use Pythagoras theorem to get the value of BC, we find the perimeter excluding the floor, mention that, and the surface area excluding the floor of course will be perimeter into the depth. You can also call it the length, that's okay, and this is the area into rate, units are same, no problem, and this is the cost. Now let's talk about Roman number 2. What is the cost of paving the floor, entire floor, at this rate? So cost will be equal to area of the floor into the rate, and the floor is again a rectangle. If you imagine this in 3 dimensions, AB is the length and the breadth is how much? 40 meters. It's a 3-dimensional rectangle. So length into breadth gives you area, and area into rate gives you the cost. So mark this sum as IMP. The next sum, the 5th sum, also mark it as IMP. Now this type of sum is called a rate of flow of water type of sum. For that we have another formula. Water, the volume of water in 1 second is equal to the area of cross section into speed of flow of water. Now again, let me explain this with the help of a diagram. Imagine there is a pipe and the cross section is this circle and water flows out of it. If instead of water, ice would come out of it, then I could actually imagine this to be a cylinder. And what is the volume of the water flowing out? Well, it's the same as the volume of this pipe, which is also a cylinder. And we just saw that the volume formula is area of cross section into the depth. So suppose say the area of cross section is 10 centimeters squared and the depth is 10 centimeters. So what is the total volume of water coming out? 10 into 10, 100 centimeter cube or 100 milliliters. So based on this, we have a formula that volume per second is equal to area into speed of the flow of water. The actual formula was volume is equal to area into length. Now if I divide this by time and even this by time, what is length upon time, or rather distance upon time? That is called speed. And volume upon time is volume per second. So we have a direct formula, volume per second is equal to area of cross section into speed of water. That's it. This one formula can be used to solve any type of sum regarding flow of water, or for that matter any other liquid. So let's apply this for the 5th sum. They have given the area of cross section as 2 centimeter squared. That's the circular area. And they've even given the total volume of water, and they've asked for the speed. That seems easy. Volume is equal to area into speed. Volume is given, area is given, we can find the speed. Simple. But the units are all different. Area is in centimeters square, volume is in liters of water, and it is not per second volume, it is 5 minutes volume. And the speed they want is in meters per second. So conversion of units is the challenge in this sum. First, since the volume is given in liters, we will convert it to centimeter cube. We could have converted to meter cube also, but I prefer this. Multiply it by 1000, so you get 1,500,000 centimeter cube volume. But that is not per second volume, it is a 5-minute volume, that is 300 seconds. We need to find the per second volume, which comes out to be 5000 centimeter cube. Now, the formula is that volume per second is actually area of cross section into speed, and volume we found out, that means area of cross section into speed is equal to 500. Area of cross section is already given 2 centimeters squared, and that is why I used centimeter cube, because I want the units to be same. But then the speed also will be in terms of centimeter per second. So that's how you find the speed. But they want the speed in meters per second. That's easy. Let's just divide it by 100 and you get the answer as 25 meters per second. Next, the 7th sum. Here the total volume of rectangular tank is given. It's 80 into 60 into 60, which comes out to 2,88,000 centimeter cube. It is filled by a pipe whose cross-sectional area is given and whose speed of water is also given. Well, if area is given and speed is given, what can we find out? We can find out the volume per second. So let's find that out. First of all, let's convert the speed into centimeters per second, because the area of cross section was in centimeter squared. And using the usual formula, we can find the volume per second. That means in 1 second, 480 centimeter cube of water flows out of the pipe. That means in the tank, per second, 480 centimeter cube of water is filled. But the total volume of the tank is 2,88,000 centimeter cube. So how much time will it take? Well, you can use unitary method and the answer will be 600 seconds. Do convert it to 10 minutes, because we never speak about time as 600 seconds in practical life. Now the 9th sum. There is a swimming pool. It is 18 meters long and 8 meters wide. That is a top view. Its deep and shallow ends are 2 meters and 1.2 meters respectively. You are aware that in a swimming pool, we may have different depths at different places. So we have to find the total capacity or the volume of the pool. Drawing a diagram will make it easy. And the diagram is like this. So this is a top side view. From the top, if you look at the water, it's 18 meters by 8 meters. On one side, the depth is 1.2 meters. And on the other extreme, it's 2 meters deep. And of course, this is the floor. And the floor is sloping gently. What is the volume? Well, the volume would be area into the depth. Here, let's not call it the depth because it is confused with this depth. So let me call it the width. If we can find the area of the trapezium, which is actually a slice of the swimming pool, and multiply it with this width, we can get the volume of the swimming pool. Then this diagram is similar to this question number 2 diagram, which is a similar sum, but it's easier because the diagram is made for you. This is a cross section, a side view, and the width here is also 40 meters. Imagine this in 3 dimensions. Here's you floating in water, and here's you standing in water because your feet touch the floor. Imagining you are 1.5 meters long. So how do we find the area of the trapezium first of all? Well, we have all the information we need to find the area. The formula is half into height, that is the distance between the parallel faces, multiplied by the 2 non-parallel sides. I beg your pardon, let me repeat that. half into the height into a plus b, or you can say half into the distance between the parallel sides into the length of the two parallel sides. If you wanted to find the area of this trapezium, it would be half into 40, which is the distance between the two parallel sides, which I call as the height, multiplied by, in brackets, 1.5 plus 3, which are the two parallel sides. So we find the area of the trapezium, and if you multiply it with the width, you get the volume, and that's how the sum is done. Next, the 10th sum. The 10th sum is quite challenging. This is a podium. Gold medalist, silver medalist, and the bronze medalist can stand on this, but we need to find its total surface area and its volume. Now, if you look at the surface area, I can divide this into three rectangles, 1, 2, 3. So these three areas can be found out with the help of the dimensions given. Similarly, the back portions area can also be calculated. Then we have the side portions. This is a side portion, top portion, side portion, top portion, side portion, top portion, and side portion. So many rectangles to add. The base is not to be counted because a podium never has a base. It is hollow, and that's because it is kept on the ground, so nobody's going to look at the bottom anyway. If you have to paint it, you won't paint the bottom at all because there is no bottom. So don't count that surface. So totally, how many rectangles did we just have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and behind 3. So 13 rectangles. Calculating that way would become too long and tedious. So we'll use a simpler method. Yes, we'll find these three areas separately, and let's do that first. Area of number 1, well, this is 30, but what about this height? How much is this? If you notice, this much is 30 and this much is 30. That means that totally it is 60. So 30 into 60, area is 1800 centimeters squared. What about this area? 30 into 30 is 900 centimeters squared. And here 20 into 30 is 600 centimeter squared. So the total front side area, just add them, and it's 3300 centimeters square. And now you know the back side area will also be 3300 centimeters squared. So that's done. Now the only thing left are these areas, these side areas and the top areas. Don't calculate them separately. How about this idea? We'll find the perimeter, this perimeter, and multiply it with the depth to get the total area. Just like we did it for this tunnel. In the tunnel also, we just calculated the perimeter and multiplied with the depth. Similarly here, just get the perimeter, don't count the bottom, okay, and then multiply with the depth, and you'll get the total area in one shot. So perimeter is, this is 20, okay, this is 30, okay, how much is this? Well, I know that totally this is 60, out of which the small portion is 20, so this seems to be 40, so this will be 40. So 20, 30, 40, 30, 30, 30 and 30. So totally the perimeter excluding the base, should write that. So write front side perimeter excluding the base is 20 plus 30 plus 40 plus 30 plus 30 plus 30 plus 30, 210 centimeters. And the top surface area, the top and the side surface area totally is the perimeter into the depth, and depth is given as 40 centimeters. See here, it's 40. Of course, it will be 40 everywhere. 40, 40, 40. It's 40. The depth is always 40. So the total surface area now is this 8400 plus the front side plus the back side. Totally 15,000 centimeters squared is the answer. But the sum isn't done yet. They even want the volume. Now you can either find the volume of 1, volume of 2 and volume of 3 and add them, or use a short formula. What was it? Volume is equal to the total area into the depth. Now the front side area we already know. it's 3300. So just multiply it with the depth, which is 40, and you get the volume as 1,32,000 centimeter cube.